Before concrete becomes a column, a beam, or a wall, it's a liquid. And like any liquid, it needs a container to hold its shape until it turns into a solid. That container is formwork, and it's one of the most critical, yet often overlooked, aspects of concrete construction. A formwork failure isn't just a messy leak, it's a sudden, violent collapse that can cost tens of thousands of dollars and put lives at risk. But beyond safety, the quality of your formwork directly dictates the quality of your final concrete surface, its smoothness, its dimensional accuracy, and its overall aesthetic. In this video, we're pulling back the plywood to reveal the engineering, the planning, and the on-site execution that goes into building the perfect mold. We'll explore the different systems, the science behind the pressures involved, and the pro-level secrets to achieving a flawless finish every single time. Let's start with the fundamental force that governs all formwork design: concrete pressure. When you pour concrete into a form, it doesn't just sit there passively. It behaves like a thick fluid, exerting hydrostatic pressure on the sides of the formwork. This pressure is at its maximum at the bottom of the pour. The key factors are the density of the concrete, the rate of pouring, and the temperature. A fast pour with cold concrete is a recipe for extremely high pressure. There's a simple formula engineers use, but the practical takeaway is this: the taller the wall or column you raise pouring in one go, the more pressure you have to contain. This is why you see robust whalers, strong backs, and heavy-duty ties on deep pours. A pro tip from site engineers is to always use a vibrator carefully. Over-vibrating not only causes segregation of the concrete mix but also temporarily liquefies the concrete, significantly increasing the pressure on the formwork panels and risking a blowout. Now, let's break down the most common types of formwork, starting with the most basic, traditional timber formwork. This is the on-site, cut-to-fit system using timber planks and plywood sheeting, supported by timber joists and soldiers. It's highly flexible and perfect for complex, one-off shapes or small, or regular projects. However, it's labor-intensive, time-consuming, and has a short lifespan as the plywood degrades with each use. The next step up is engineered prefabricated systems. The most common of these is the aluminum formwork system. This is a lightweight, modular system of panels, pins, and wedges that can be assembled like a giant Lego set. Its huge advantage is speed and reusability. It can be used hundreds of times, making it incredibly cost-effective for large, repetitive projects like residential apartments where the floor plans are identical. The efficient workflow secret with aluminum forms is the table form or flying form system for slabs, where large sections of decking and supports are pre-assembled and then lowered and moved as a single unit by a crane, dramatically reducing cycle times. 4. Massive structures like bridge piers, cores, and high-rise shear walls. We use specialized climbing formwork. This is a self-contained system that climbs up the structure as it grows. It consists of a working platform and form panels that are anchored into the previously poured concrete. After a section is poured and sets, the entire form is released and lifted either by a crane or using hydraulic jacks to the next level. This eliminates the need for cranes to handle individual formwork panels at height, making it much safer and faster for constructing tall cores. A common and catastrophic drafting mistake is to forget the anchor embeds or to misplace them on the structural drawings, leaving the climbing formwork with nothing to attach to. Another advanced system is slip forming, used for extremely tall, constant section structures like silos or towers, where the formwork moves continuously, 24/7 as concrete is poured, allowing for seamless, monolithic construction, no matter the system. The principles of good formwork practice are universal. First, it must be rigid and strong enough to carry all the dead and live loads without deflection. A visible bow in a formwork panel will become a permanent, ugly bulge in your finished concrete. Second, it must be watertight. All joints must be sealed with specialized formwork tape to prevent grout loss. Those unsightly fins and discolored lines on concrete surfaces are almost always the result of leaking joints. Third, and this is a major pro tip, the inside face of the formwork that contacts the concrete must be treated with a release agent. This is a special chemical spray that prevents the concrete from bonding to the formwork, allowing for clean, safe stripping without damaging the concrete surface or the formwork panels. Using old engine oil is a classic, unprofessional mistake that stains the concrete and ruins the formwork plywood. The final act is the striking, or stripping, of the formwork. This is a delicate operation guided by the engineer's instructions. You must wait until the concrete has gained enough strength to support its own weight and any construction loads. Stripping too early can lead to sagging, cracking, or even collapse. The sequence is also critical. You typically remove the side forms of a beam or wall before the bottom soffit forms, as the concrete will have gained enough strength to support itself vertically but may still rely on the soffit for full bending capacity. After stripping, the formwork must be cleaned meticulously of any hardened concrete before being reused. A disciplined crew that cleans and stacks forms properly will save countless hours and dollars on the next use. To summarize the key takeaways: 1. Formwork must be designed for the immense fluid pressure of wet concrete, which is influenced by pour rate and temperature. 2. The system choice, from flexible timber to fast aluminum to advanced climbing forms, is a balance of project scale, complexity, and budget. 3. Success hinges on rigid construction, sealed joints, and the use of a proper release agent. And 4. Safe stripping according to a prescribed sequence is non-negotiable for structural integrity. Now, I want to hear from you. In the comments below, what's your biggest formwork challenge? Is it dealing with the high pressure of a fast pour, achieving a perfect architectural finish, or managing the logistics of a large modular system? Your field experience is invaluable. If this guide to the world of formwork has been helpful, please give this video a like and subscribe.